So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some GCSE Maths higher big mark questions taken from some past papers. Now as always there'll be a copy of the question paper along with the mark scheme for you to download and have an attempt at before watching this video as we go through the answers. So as you can see in the topic breakdown of these questions that we're about to go through in this video, that they're all centred around geometry and measure with a mix in of some algebra and some number. So let's get started on these questions. Let me just zoom in so we can see it. Now again, if you've not had an opportunity to print off any of these questions, then feel free to pause the video as I read through the question and then unpause to go through the answer. So looking at this question 1, it says that ABC is a cyclic quadrilateral. Work out the values of x and y. So then recalling some of these circle theorems that hopefully you would have remembered, is that one of them with regards to a cyclic quadrilateral is that opposite angles add up to 180. So this angle here and this angle here will add up to 180. So x plus y plus 70 equals 180, and if I neaten that up I get xy equals 110. Then if I look at the other opposite angles, I work out that x plus 2y plus 40 add up to 180, and if I neaten that up I get x plus 2y equals 140. Now as you can see, I've set up two equations with two variables, so then I'm going to be using simultaneous equations to work that out. So what then I'm going to do is x plus 2y equals 140 and x plus y equals 110. So as you can see, I've got the x is the same and they're both the same sign, so I'm going to take away the two equations. So x take away x is nothing, 2y take away y is just single y, and the difference between the numbers is going to be 30. So y equals 30. Then from this, if I use one of the equations, so let's just go for this one here. So x plus y equals 110. I know that y equals 30, so I've got x plus 30 equals 110. So x equals 80 degrees, and there are my two answers. Then moving on to question 2, it says the area of the triangle is 45 centimeters squared, and it says work out the value of x. So for this, what I need to do is, because I don't know the perpendicular height, I know that the area is equal to half AB sine C. So labelling this triangle, this is going to be C, that's going to be A, and that's going to be B. So substituting numbers in, I've got 0.5 multiplied by 3x multiplied by 5x multiplied by sine 30, and that equals 45. So then neatening all of this up, well, I know that sine 30 is going to be a half, and I know I've got a half here, and I've got 3x times 5x. So if I just turn all of these into a fraction, and that equals 45, then what I've got at the top, I've got 15x squared over 4 equals 45. So then here 15x squared equals 4 times 45, which is going to give me an answer of 180. So if I just move over here, 15x squared, so then take the 15 over to this side by dividing by 15. So then how many 15s go into 180? Well, that's going to be 12. So x squared equals 12. So x equals the square root of 12, or we could write it in third form, which is going to be root 4 times root 3, which is 2 root 3. So I can either write the answer as root 12 or 2 root 2. And any of those would be absolutely fine, or root 3 rather, not root 2. And there we go. Moving on to question 3, it says the area of the trapezium is 280 centimeters square to the nearest 10 centimeters squared. The lengths are 13 centimeters, 18 centimeters are given to the nearest centimeter. Work out the maximum possible value of the height. So for this, what we need to do is, first of all, let's look at the bounds of each of those lengths. So here we've got 13, so that's going to be to the nearest centimetre is going to be 12.5 and 13.5. With 18, that's going to be 17.5 and 18.5. And then with the area, which is 280, well, the upper and lower bound to nearest 10 is going to be 275 to 285. Now for this, what we need to do first of all, we know that the area of a trapezium, so let me just write down the formula, is going to be A plus B times H divided by 2 equals A. And if I just write that as, so I don't have a fraction, that's going to be A plus BH equals 2A. Now, what you then want to do from this stage is if I take this A plus B over to the other side, so what I end up with is H equals 2A over A plus B. Now, if you looked at bounds and trying to get the maximum H, so the maximum values of this fraction, we want this to be the biggest and this to be the smallest. So in order to work out what the maximum height is going to be, I need to have the maximum area, which is this value here, and I need the smallest AB value. So if I just write AB, and that's capital A. So I want this number, oh, not that one. I need this one here and this one, the lower bounds of A and B, and the upper bound for the area. So substituting all of those numbers in, I get H equals, and it's going to be 2 times 285 over, and it's going to be 12.5 plus 17.5. And if I type that all into my calculator, I get a H value of 570 divided by 30, in which then I get H equals 19 centimeters, and there is my final answer. Moving on to question 4, it says the diagram shows a square-based pyramid, not square, of OABCD. It says OA, OB, OC, OD are 6 centimeters, and AB is equal to BC, which is 4 centimeters. And the question is asking us to work out the size of angle OA and the base ABCD, marked X on the diagram. So I need to work out what this angle here is. Now, first thing, so if you've seen these questions before with 3D trigonometry, it's always helpful to try and map out where you see right angle triangles. So the two triangles I'm going to be using is that green triangle and this blue triangle. Now, with regards to this, in order to work out X, I need to work out what AC is. So here, if I just draw that blue triangle out and just label it accordingly, I've got this is 4, and I'm going to call this side here X. So then using Pythagoras to work this out, I get X squared equals 4 squared plus 4 squared. So X squared equals 32, and so X equals the square root of 32, or I can write that as 4 root 2. So from this, what I can then do is then work out from this what, if I just label this point as M, I can then work out what M is going to be. So therefore M, or AM I should say, is going to equal 4 root 2 over 2, cancel the 2's, so then it becomes 2 root 2. And that is this length here. So if I then take that green triangle out, now this is the X that really probably shouldn't have used X. Let's just change that for a while, though it may be a bit too late to do that. So then from this, I've got this length here as being 2 root 2. Let me just label this triangle again. Oh, this is the angle X, and I know that AO is 6 centimeters. So from this, I can then use trigonometry to work this out. So this is the hypotenuse, this is the adjacent, this is theta. So I'm going to be using cos, so cos X equals 2 root 2 over 6. So cos X equals, and it's going to be root 2 over 3. And I can just type that in, so X equals the inverse cos of root 2 over 3. And on the calculator, that gives me an answer of 61.8744943. So X equals 61.9, and that's to 1 decimal place. Moving on to question 5, it says that ABC are points on a circle with centre O. AB is the diameter. The ratio of the size of the angle X to the size of angle Y is in the ratio of 5 to 1. Work out the size of angle Z. So as A to B are the diameter of the circle, then basically what that means is that this angle here has got to be a right angle. So ACB is a right angle. Now, again, there's no indication of whether we need to write down the proofs of that, but basically if I needed to, ACB equals 90 degrees, and if it's the semicircle rule. I'm just going to write semicircle, but we could expand on that if it needed it. So we know that the total of this angle is 90, so x plus y equals 90, so that's my total. And I want to split that in the ratio of 5 to 1, where x is 5 and y is 1. So here 90 divided by 6 is 15. So x equals 5 times 15, which is 75, and y equals 1 times 15, which is 15. So this angle here is 15 and this angle here is 75. Now this triangle COB is a isosceles triangle because CO and OB are the radius of a circle. So again, if you needed to explain it, then that's what you do. So this, therefore, that angle here, as it's an isosceles triangle, must equal 15. So to then work out what this angle here is, well, that's going to be, let me just use a different colour. So to work out this angle here, that's going to be 180 minus 15 minus 15, which is 150. Then to work out what angle Z is, I then need to, because it's on a straight line, it's going to be 180 minus 150, which equals 30 degrees. So Z equals 30 degrees. Then moving on to question B, it says L, M and N are points on a circle. PLQ is a tangent. Work out the angle of MLN. So then looking at this, as PQ is a tangent, it means that this angle here of NML or LMN is also going to be 80 degrees, and the reason why that is because it is a alternate segment theorem. So let me just write that down. So LNML, which is equal to LMN, equals 80 degrees, and the reason for that is the alternate segment theorem, or AST I could write. So then as that's 80 degrees, I can then work out what this angle here is, which is the angle that they wanted me to find, because angles in a triangle add up to 180. So angles in a triangle, what do I write is there? Let's just write it properly. In a triangle add up to 180 degrees. So 180 minus 58 minus 80 is going to give me an answer of 42 degrees. So the angle MLN equals 42 degrees, and I could just write it there, and there we go.